Hello friends, welcome back to your UPSC. Today in Oceanography we will be completing oceanic movements which involve oceanic waves, current and tides. So let's get started. So in oceanic movement we will first start with oceanic waves. Oceanic waves are undulation in the surface layer of both large and small bodies of water. See, whatever undulation that we see on the surface layer of the water body is known as waves. Okay, and this waves, it involves transmission of energy and movement by the means of vibratory impulses through various states of matter. Okay, so here we can experience vibratory impulses. Okay, these vibratory impulses, they causes transmission of energy and momentum. Okay, and this leads to formation of waves. Now we basically have three type of waves. First is longitudinal wave. Longitudinal wave, it moves to and fro in the direction of movement of water. Okay, so if the water is moving this side, so in this line only it is parallel to the movement of water and it will move to and fro. Okay, so these true to and fro movement are involved in longitudinal waves, while in transverse wave we can experience the movement of waves is perpendicular to the direction of movement of water. Okay, so here the movement of water is like, sorry, movement of wave is like up and down. Okay, lastly we have orbital waves. In orbital waves we can see that the waves follow a rotatory motion. So this circular motion of wave is known as orbital wave. Okay, now we will look into wave characteristics. Now waves are, the most important cause of wave formation is winds. Winds are the major factors that causes the formation of waves. Okay, second is wave have definite direction, so they move in a specific direction. Lastly, they are having 2D movement. Okay, so here we can see they have 2D movement. Now to understand waves, we need to understand the basic terminologies of waves. So we have, consider this as the coast, and here we have sea level. Okay, this is our sea level. Now these are the waves generated. Now these waves that are generated are known as swells. Okay, now these swells, what happens is when we have one wave, so one, it has crest and trough. Okay, so this is the crest and this is the trough. Okay, like we have waves, so these are also similar to them. So when one crest is overlapped by another crest, so the energy doubles or energy increases, and this energy, it leads to the formation of bigger crest and bigger trough. Okay, so what happens here, when one wave hit the shore, the another wave just coming after that, the first one, it superimposes it, and we have bigger wave and bigger trough. Okay, so these bigger waves and bigger troughs, normally we have U-shaped configuration, but when the trough it increases, it acquires a V-shaped configuration, and the velocity and the impact of this wave increases, and this wave is known as surf. Okay, surf. Surf is same swell, or we can say simple wave, water wave, which is having higher intensity. Okay, so when we have surfs at the coastline, there is a game known as surfing, and this game is played when we have surfs. Okay, now when these waves they hit the shore, so these waves when they hit the shore, they are reflected back, and this reflected back, the waves that are reflected back, they are known as backwash. Okay, then we have undertow. Undertow is the current which is not flowing, which is not on the surface, it is just beneath the waves. Okay, so it is a current that is flowing beneath the backwash. Now these two are important for the creation of coastal landforms. Okay, so these type of waves that are important for the creation of coastal landforms are known as constructive waves, while other waves like tsunami, then we have landslide surge. These are destructive waves. These waves, when generated, they destroy the whole coastal topography or landform. Okay, so these are destructive waves. Now we have breakers. What happens when the waves are moving? They hit some surfaces. Okay, like we have rocks. Okay, so when they hit the surfaces, their height increases. So these surfaces that they hit are known as breakers. Okay, so this was all about waves. Now we will look into oceanic tides. Now tidal phenomenon, tides if we talk about, they are rhythmic raise and fall of seawater caused by combined gravitational effect of celestial bodies like moon, star. So the gravitational force of moon and star, they cause rhythmic raise and fall of seawater, and this rhythmic raise and fall of seawater is known as tides. Okay, the oscillation and undulation caused by gravitational attraction of moon and sun also generate tidal waves, leading to transfer of energy and momentum from one place to another. So we know that what actually waves are, they are transfer of energy from one place to another. Now because of oscillation and undulation that is caused by gravitation, or simply we can see the tides also generates tidal waves, and these waves lead to transfer of energy and momentum from one place to another. Okay, now gravitational attraction, we can simply say it is the impact of gravitational attraction is proportional to the product of masses, like mass of, if the we have two bodies having mass of m1 and m2, so product of their masses, and so this is m1 m2, it is inversely proportional to square of distance between them. Consider the distance between them to be d, so it is inversely proportional to the square of distance between them. So we can simply say gravitation is equals to m1 m2 upon d square. Okay, And the basic mathematical formula for the gravitational attraction is G, this is gravitational constant, M, M1, M2 we can also say, or this is also correct, upon R square. Okay. So these are the masses of two body and this is the distance between them and this is gravitational constant. Now, to understand the tidal phenomenon better, we need to understand the phases of moon first. So starting with the phases of moon, we first have new moon. New moon occurs when the sun is in the direction of moon. That means this is the moon and this is the sun. So we cannot see the part of moon because the part of moon that is facing the earth is on the darker side. Okay. So this is new moon. Then going further, we have waning moon, waning crescent. So waning crescent starts when the slight or the small part, that is 1/3 part of the earth, this moon, is visible to the earth. This new moon occurs during Siski and full moon also occurs during Siski. Okay. Siski is the position when sun, moon and earth, they are in a straight line. Okay. So this is during Siski and this is also during Siski. Then we have waning crescent. Then we have first quadrant. In first quadrant we can see half moon and this first quarter we can see half moon and this position is known as quadrant position. Quadrant position is when the sun, moon and earth are at 90° or they are crossing each other. Okay. After this we have waning Gibson. Waning Gibson, in this we can see 2/3 part of the moon. This is 2/3 part of the moon that is visible to the earth and this is known as waning gibbous. Okay. Lastly, the sun's light fall directly on the face of moon that is facing the earth. So this part of the moon which is having light is towards the earth, so we can see the full moon and this is known as full moon and this also occurs during Siski. Okay. After that we have waxing gibbous. Waxing gibbous, again we have 2/3 part of the moon that is visible to the earth and because now the size of the moon will start depleting, this is known as waxing. Okay. Gibbous means 2/3 part of the moon is visible. Now on second third quadrant we can see half moon and lastly we can see 1/3 moon and this is known as waxing crescent and then again the phase of new moon starts. Okay. And this takes total of 29.5 days. Okay. And this is known as lunar month. Now during the situation of full moon and new moon, the earth experiences high tide and during the situation of quadrature, the low tides are experienced. Okay. So we have like this during the quadrature and during the Siski we have comparatively higher tides. Okay. If we consider this as the sea surface. Now we have already seen that the rotation time that a tide takes is 29.5 days. Now at a time when tide occurred, so we have two consecutive high tides and two low tides. Okay, so if the tide is occurring, then we will have two consecutive high tides and low tides. Okay, two low tides at a time. Okay, now there is total of 52 minutes of delay after full rotation of the earth when we have tide here in this position of the earth. Now the next tide will occur after that will occur after the full rotation of earth. It will be delayed by 52 minutes. Okay, now this delay is because of slow rotation of moon. So now this area will again experience tide after 52 minutes, the same type of tide. Okay, and the next tide at the same place, that is if we are experiencing high tide, then we will experience low tide at the same place, because due to rotation the tide will shift. Okay, now we will be having this type of tide. So this area will be experiencing next tide with the delay of 13 minutes. Okay, so this is basic calculation, and because we are having 13 minutes delay, so the same position of the tide will be after 13, 26 minutes, 39 minutes, then at last 52 minutes. Okay, so this is how 52 minutes delay we have for the same tide to occur at the same place. Okay, now we will look into different type of tides. So we basically have 6 different type of tides. First we have spring tides. Spring tides are very high tides that are caused when the sun, moon and earth are almost in the same line, and such high tides are known as spring tides. And this position of the sun, moon and earth when they are in straight line is known as syzygy. And this position is also known as the position of conjunction when the earth, sun and the moon are on one side of the earth. Okay, so this is earth and this is the moon and this is sun. Okay, this position is known as conjunction, and the conjunction position is the situation of solar eclipse. And now when the position is opposite, like when the sun and moon, sorry, the earth is between sun and moon, this is our earth, this is sun, and this is moon and this is sun. So this position is known as the position of opposition, and this causes lunar eclipse. Okay, and during this time we have spring tides that are caused, and during this position we have full moon and new moon that occurs. Okay, so at this time we have full moon and new moon occurring. Next we have neap tides. Neap tides are when the sun, earth and moon come in the position of quadrature, that is they form the right angle on the 7th and 8th day of every fortnight of the month. Okay, so we have moon, then we have earth, and this is our sun, so they are at the right angle. So this time a low tide occur is caused, and this lower height of the tide than the normal tide is known as neap tide. Okay, and this height of the neap tide is generally 20% lower than the normal tide, and the spring tide height is 20% higher than the normal tide. Next, we have tropical and equatorial tide. Tropical and equatorial tide, we can simply say that this the sun there is, when we have sun, we have northward and southward position of moon in relation to the equator of earth, like the sun. Okay, so like the sun, we have northward and southward position of moon. Now if the sun completes northward and southward position in a year, then the moon completes it in 27.5 days, and this is known as synodic month. Okay, now when there is maximum declination of the moon to the north of the equator, the moon rays fall vertically on the tide center near the Tropic of Cancer, and hence the spring tide is caused. And such type tropical tide, so here, so like this we have tropical tide which is occurring on Tropic of Cancer, and other time Tropic of Capricorn. Okay, so these are known as tropical tide. And now as the rays of sun, they are always vertical on the equator, so there is no inequality in the tides in term of height. If we look into neap tide and spring tides, so we have equal height of tide at the equatorial region, so this type of tides are known as equatorial tides. So the spring tides, when they occur on tropical region, they are known as tropical tides. We can have tides on Tropic of Cancer and Capricorn, and then we have tides on equatorial region. They are not classified as neap or spring tide, so they are known as equatorial tide. Now the tides, when they are caused due to positioning of sun, so when the position of sun is nearest to the earth, this position is known as perigee, and the tidal force of the moon is most powerful during this position, and the high tide is caused, and this tide is known as perigean tide, and the tide caused during the apogean phase, it is known as apogean tide. Okay, then we have daily, or we can say diurnal and semi-diurnal tide. So the tide reoccurring at the interval of 24 hours and 52 minutes daily are known as diurnal or daily tides, and the tides that are occurring at the interval of 12 hours and 26 minutes are known as semi-diurnal tides. So at the same position, sorry, the tides that are occurring in one day, okay, are known as diurnal tide, and they occur at the time interval of 24 hours and 52 minutes. Okay, so they are known as diurnal tides. And then we have the tides that are occurring at the interval of 12 hours and 26 minutes. They are known as semi-diurnal tide. Now lastly, we have equinoctial spring tides. Equinoctial spring tides, these are the tides that are reoccurring at the interval of 6 months due to revolution of earth around the sun and sun's varying declination. Okay, so sun, due to the movement of sun, we have northward and southward movement of sun. Okay, so because of the positioning of sun, the interval of tide is 6 months, and the tides occurring at the interval of 6 months are known as equinoctial spring tides. So these were the type of tides, and this was the whole concept of tide. Now we will look into oceanic currents. Oceanic current, we can simply say that they are the mass of oceanic water, and this mass of oceanic water, when it moves in a definite direction, it is known as oceanic current. Okay, so we have good amount of mass of oceanic water that is moving in a particular direction is known as oceanic current. Now we have differentiated, or we have classified current into two basic types, and first classification is on the base of temperature. So on the basis of temperature, current can be classified as cold current and warm current. So the cold current, one which are coming, the water, mass of water which are coming from the poleward side and carrying cold water, they are known as cold current. And the other one which are moving from the equator towards the pole side, they are known as warm current. And classification on the basis of velocity, we have three types of current. First is drift, second is current, and then we have streams. So this is having the least velocity and this one is having the highest velocity. Now we will look into various factors that are involved in the formation of ocean current. So the first factor is related to the rotation of Earth. Now, the rotation of Earth on its axis from west to east, it results in the genesis of deflection of forces, and this deflection of forces is known as Coriolis force, and this Coriolis force, it deflects the general direction of oceanic current. So, as we have seen, if the this is the direction of oceanic current in the northern hemisphere, and in the southern hemisphere, here the water will deflect towards its right hand side, and here the water will deflect towards its left hand side in the southern hemisphere. Okay, so this will form an equatorial current on the equator. Okay, so this is cause of rotation of Earth. Then we have factors related to ocean. In factors related to ocean, there is variation in various physical properties of ocean, that is temperature gradient, pressure gradient, and then we have salinity difference, density difference. These difference, they generate oceanic current. Like if we have temperature difference, then the water moves from higher temperature area towards the low temperature area. Okay, and to count, then we have salinity difference. Now oceanic salinity, it also affects the density of water, and the density variation, it causes the oceanic current. Now if the salinity increase, the density of ocean water increase. Okay, and the area having higher density and the area having lower density, we will see that the water moves towards the area having greater density. Okay, and this also generates oceanic current. Then we have factors related to atmosphere. We have air pressure and wind. So the air pressure, if we have higher pressure, and here we have lower pressure, so the wind will move from high pressure area to low pressure area, and with the wind, when it is moving on the surface of water, it will drag the water with itself, and this will form current. Okay, and this happens with wind also. Then we have rainfall and evaporation. So rainfall, due to rainfall, the salinity of the area, it decreases, and because of decrease in salinity, the density of the area decreases. And see, if we have this high density area, and here, because of precipitation, this becomes the low density area, then the water movement will be reversed, or if it becomes comparatively lower density area, then the force of attraction will be lower, and the evaporation, it causes increase in salinity of the area and thus leading to higher density area. Okay, so these are the factors that are involved in formation of ocean current. Now there are various factors that are involved in modification of ocean current. So the first one is direction, shape and configuration of the coastline. So if we have tilted coastline, then the direction of the current will also change. Likewise, if we have rough coastline, then the speed of current will decrease. So this is how the current is affected by them. Next we have bottom reliefs. So bottom reliefs, they actually comes as a breaker, or we can say they act as a hindrance in the movement of water, and because of them the velocity of the current, it decreases. Then we have seasonal variation. Seasonal variation, consider that we have high temperature in one area and then we have lower temperature in another one. So water will always move from high temperature area to lower temperature area. Now if during winters, sorry, during summer, this low temperature area, here also temperature increases, then the movement of water will either stop, and if the high temperature during summer is not that high, then the movement of water will continue, but it will be slow. So this factor, these three factors, they are responsible for modification of ocean current. Now as we have done the ocean current, now we will look into the distribution of ocean current in the three basic or three major oceans. Now first we will talk about the Atlantic Ocean. In the Atlantic Ocean, first we will look into the configuration of oceanic current in the northern Atlantic. So in the northern Atlantic, we will see that this is, firstly we will mark the equatorial region. So this is our equator. Now the oceanic circulation in the North Atlantic is highly influenced by several geomorphological, climatological and oceanographic factors. Now starting with the current, the North Equatorial Current originates from the western margin of Africa by the frictional drag of easterlies. So because of frictional drag of easterlies, we have formation of North Equatorial Current. Now the North Equatorial Current, it bifurcates into two branches near the bulge of Brazil. So this is the bulge of Brazil. Okay, and here it bifurcates into two. Now we can consider this in the south equatorial current of Atlantic Ocean. So first we will see in the North Equatorial Current. So we have this North Equatorial Current. Now North Equatorial Current, as it strikes South American coast, it moves towards North America. Okay, so in North America, here we have Altai Islands. So these Altai Islands, as the water strikes, it divides into two parts. So this is Altai current. This Altai current, as it strikes as this North Equatorial Current, it strikes the Altai Island. The Altai Island, it forms Altai current, and this Altai current, it moves northward. Okay, now forget about this. The westward current, it moves towards the Gulf of Mexico and the Caribbean Sea. Okay, now here the oceanic current start to be known as Caribbean current. Okay, and this oceanic circulation, it accumulates abundant amount of water within the basin of Gulf of Mexico. Okay, so this is known as Caribbean current, and this is known as Altai current. Okay, so this Caribbean current, it accommodates, or it accumulates abundant amount of water within the basin of Gulf of Mexico and develops a gradient in the south north direction to give rise to massive system of oceanic current, and this massive system of oceanic current is known as Gulf Stream. So as it, firstly it will move out, and the one which is moving out is known as Florida current, and this Florida current is then changed into massive stream known as Gulf Stream. Okay, so here we have Gulf Stream. It is basically the system of current having three branches, that is Florida current, Gulf Stream, then North Atlantic drift. So the Florida current, it moves from Florida to Cape Hatteras. Okay, and then we have Gulf Stream. Gulf Stream, it moves from Cape Hatteras. Here we have Cape Hatteras to Newfoundland. So Newfoundland. Now, then we have North Atlantic drift. North Atlantic drift, it moves from Newfoundland, Newfoundland to Western Europe. Okay. Now, near Newfoundland, again the Gulf Stream, under the frictional drag of westerlies, it acquires northeast direction. Now, here we have frictional drag of easterlies, so it will acquire northeast direction. Okay. Now, the respective circulation is known as North Atlantic drift. So here we have North Atlantic drift. Okay. Now, this near 40° north latitude, the Central Atlantic Ocean, in the Central Atlantic Ocean, by the orographic abundance of mid-Atlantic ridge, again the North Atlantic drift bifurcates into two branches, that is northern and eastern branch. So here it bifurcates into two. So we have, first is the northern branch. It further divides into two minor branches, of which one reaches along the southern coast of the islands of as the Irminger current, and while the other, it enters Norway Sea as Norway current. Okay, so here we will have, this is Iceland. So this branch is known as Irminger current, while the branch moving in the Norwegian Sea is known as Norwegian current. So this is our North Atlantic drift. Sorry, this is our North Atlantic drift. And this North Atlantic drift, it bifurcates into two. And this two bifurcated, the north one is again bifurcated into two subparts. This one is known as Irminger, and the lower one is known as Norwegian current. Okay. Now, similarly, the eastern branch near the Western Europe also bifurcates into two branches. So this branch, it also bifurcates. So one will enter the Bay of Biscay as the Rainal current, while the other here, this is the west one. So one will enter the Bay of Biscay and other will enter the Mediterranean Sea. So one entering the Bay of Biscay is known as renal current, and the one entering the Mediterranean Sea is known as Mediterranean current. Okay. Now the whole circulation of the North Atlantic accumulate abundant amount of water along the coast of Europe and Africa and develops a gradient in the north-south direction, giving rise to a cold oceanic current known as Canary Current. Now because of accumulation of lots and lots of water here, now a cold current will be generated in north-south direction, and this is known as Canary Current. And this Canary Current is a cold current. Okay. And finally the Canary Current, it merges the North Equatorial Current again, and this completes the circulation of North Atlantic Ocean, and this is in circular form. Now between them we have a gyre formation. This is known as North Atlantic Gyre, subtropical North Atlantic Gyre, and here we have Sargasso Sea also. Okay. Now we will look into South Atlantic Current. So South Atlantic, we have first is South Equatorial Current. So this South Equatorial Current, when it strikes the bulge of Africa, it divides into two parts. So the first part, it moves northward and it gets added with the North Equatorial Current, and it forms, and it is attached with the North Equatorial Current, and it forms Canary Current and Altai Current, whatever. The other one is Brazilian Current. Now this Brazilian Current, as we move down, it comes under the influence of westerlies, and it acquires or it adopts a southeast direction, and this is known as South Atlantic Drift. Okay. And this phenomenon is further accumulates water along the southwest coast of Africa. Okay. So the southwest coast of Africa, I'm so sorry, it is not till here, it is till here only. So this will accumulate water in the southwest coast of Africa, and this will lead to the development of slope from south north direction to give rise to a cold current, and this cold current is known as Benguela current. Okay. So this is South Equatorial Current, this is Brazilian Current, and this is South Atlantic Drift. This is known as Benguela Current. Now this Benguela Current, it merges with South Equatorial Current to complete the whole cycle. Now along with this, we have a Falkland Current, that is a cold current that is coming at the eastern coast of South Africa. So this is Falkland Current. It merges with the South Atlantic Drift and it moves towards the coast of Africa. So this completes the cycle of South Atlantic Ocean. And this, here we have another gyre. This is known as subtropical South Atlantic Gyre. So this is a subtropical South Atlantic gyre. So we have Falkland Current, Benguela Current and Canary Current as a cold current. So this was all about the circulation of water or the oceanic current in Atlantic Ocean. Now we will look into the oceanic current of Indian Ocean. Now in Indian Ocean we have northern extent of the current of the ocean up to 32° north. Now here this extent, it does not extend up to the zone of westerlies, that is in the temperate region, and this area is also influenced by south, west and northeast monsoon winds. Okay, so during southeast we have, that is during winters, we have southeast equatorial current or south equatorial current meeting at Horn of Africa, while during southwest monsoon or southwest current, that is during summer, we have south equatorial current meeting at Indonesia. Okay, so during summer we will have southwest monsoon current. They move from Sri Lanka like this, and then they get attached with south equatorial current of Indian Ocean. Okay, now these south equatorial current, they are also influenced by leave-in current. These leave-in current are coming from Pacific Ocean. So these are leave-in current. This is our southwest monsoon current. Now these southwest monsoon current, when they come towards the Madagascar island, they are bifurcated into two parts. So here we have Mozambique current, here we have Madagascar current, and these current, they merge near Agulhas and they are known as Agulhas current. Now these Agulhas current, they come under the influence of westerlies and they move towards the west, and this is known as west wind drift. And this west wind drift, some part of the current, it moves towards the Pacific Ocean, while we have other part which strikes the Australian coast and it acquires a movement in the direction of south north direction. Okay, and this current is known as Australian current. This is south equatorial current. Here we have Mozambique current. Here we have Agulhas current. Here we have west wind drift. So this is how the circulation of oceanic current is completed during summer season, and this is known as the South Indian Ocean circulation. And here we have formation of another gyre, and this is known as subtropical circulation gyre or subtropical Indian Ocean gyre. Okay, now during the winter, instead of southwest monsoon, we have the influence of northeast monsoon. Now here the movement of water will change and the water will move in opposite direction, and this will be known as northeast monsoon current, and at the equatorial region it will be moving in opposite direction, so it will be known as counter current. Okay, otherwise everything will be same except for north east monsoon current and counter current. Okay, so that was about Indian Ocean. Now there is one more thing here. In the Indian Ocean, we only have west wind drift, that is the cold current. Otherwise, the northeast monsoon, southwest monsoon, Indian counter current, or Indian equatorial current, Indian counter current, Mozambique current, they all are warm current. Okay. Now we will start with the currents in Pacific Ocean. Now let's consider this is the Pacific Ocean, and here we have equator. So this is our equator. Now starting from the northern equator, northern side of the Pacific Ocean or the North Pacific, we will have North Equatorial Current. So North Equatorial Current, it moves towards the Asian coast. Here, because it strikes the land, it deflects its direction, and now it is known as Kuroshio current. Okay, so this is our North Equatorial Current. Now this is known as Kuroshio current. Now this Kuroshio current, it comes under the influence of Kurile current. Kurile current, they are cold current. And here we have Alaskan current. Now these current, they move towards the eastern side, and this is known as North Pacific current. This North Pacific current, as it strikes the coast of California, it is actually striking the coast of California, and here it is known as Californian current. And this North Pacific current, it divides into two parts. This is known as Californian current, and the upper part is known as Alaskan current. This Alaskan current, it acquires a rotatory motion and then it again turns towards the North Pacific current. Okay. Now we have Californian current. This Californian current, it again joins North Equatorial current and thus completing the cycle of North Pacific Ocean. This North Pacific Ocean, it forms a gyre known as subtropical North Pacific gyre. Okay. Then we have South Equatorial current. Now this North Equatorial current and South Equatorial current, they accumulate a huge amount of water, and this huge amount of water that is accumulated here, it generates a gradient or a slope between these two coasts, and the water starts flowing from Asian coast towards the American coast, and this counter current is known as counter equatorial current. This counter equatorial current, it moves towards both sides. Okay. and this, the one that is moving towards the south, is known as El Nino current. Okay. Now the south equatorial current, as it strikes the coast of Australia, it forms Eastern Australian current, and another part of it moves towards Indian Ocean in the form of leave-in current, and then we have another branch which is known as Eastern Australian current. Now this Eastern Australian current, as it comes towards the south, it comes in influence of west wind drift which was coming from Indian Ocean, and it starts moving towards this South American coast, and this is also known as west wind drift. And as it strikes the South American coast, it moves towards the north, and the another branch, it moves along with the west wind drift, and it moves towards the eastern coast of South America in the form of Falkland current, which is a cold current. Okay, and this current is known as Peru current. Peru current is also a cold current. So here we have Peru current. During the period of El Nino, this Peru current is replaced by this El Nino current, and thus causing the problem in southwest monsoon. Now this Peru current, it joins south equatorial current, thus completing the whole cycle of South Pacific Ocean. Okay, and here we have formation of another gyre known as subtropical South Pacific gyre. Okay, so these gyres are actually circulation, and they form a sea inside, and here the water does not move. Okay, so these are known as gyres. So in total we have 5 gyres, 2 in Atlantic Ocean, 2 in Pacific Ocean, and 1 in Indian Ocean, because the Indian Ocean, it does not extend towards its north. So we have only one gyre, that is south, that is subtropical South Indian Ocean gyre. So this was all about the current of Pacific Ocean, and with this we complete our oceanic current of Pacific Ocean. Now we will look into the impacts of oceanic current. So firstly we can see that ocean current acts as a thermal regulator. As they transfer heat from one place to another. Secondly, we can see that the ocean current of tropical origin are characterized by high salinity when they enters into temperate zone, that is the cold zone, and it cools down, and the density of water mass, it increases. But by this phenomenon, the rate of evaporation also decreases, that is followed by condensation and cloud formation, and thus precipitation. So the other factors, if the other factors are constant, then the amount of precipitation decreases from equator towards the pole. Okay, because of oceanic current. So this is also one of the factor. Now second, we have the oceanic circulation in the tropical subtropical zone by the easterlies accumulate warm oceanic water along the western mass along the eastern coast of every continent, and the cold water mass, it upwells along the western coast to create high pressure condition. It is the matter of the common acknowledgement that the eastern coast of the continents are most turmoil and composed, and as compared to western coast. And we can also see that the western coast, because they have higher pressure. We have most of the desert that are found in western coast. Okay. Second, they affect monsoon. Thirdly, the process of El Nino that we have seen in Pacific Ocean, that is also one of the factor, or that is also one of the effects of oceanic current. Next, we have Norwegian current, which acts as thermal regulator by which the harbor or the ports of the coast of Scandinavia or Scandinavian peninsula they remains open throughout the year, because Norwegian current is a warm current, and the Scandinavian peninsula during winter the coast freezes, but due to warm current of Norway, that or warm Norway current, it remains open throughout the year. Okay. The another thing is, when the warm current and cold current meet, this place is very fertile for the breeding, or it is very good breeding ground for fishes. So here we can see the many type of fishes that are brought by different currents, and this is very fruitful for economic purpose also. And this phenomenon take place along the coast of Japan, where the Kuroshio current merges with cold Oyashi current. Okay, so these were all the impacts of ocean current, and with this we complete our oceanic currents, and thus completing our oceanic movements. So that was all for today, guys. I hope you enjoyed today's lecture. Now let's meet in our next class. Till then, take care and have a nice day. Thank you.